Yes, I actually wanted to show that this morning, but then we have changed our mind. And that is in 1984 we discovered graphene. Okay, and that is about 20 years before graphene has been discovered. And that was with an STM. I had the STM working on the bench in my lab. And in order to, that was a new development, and I called it pocket-sized STM. And it just worked. It just had a stack of plates for a vibration isolation. It was very rigid. It was very rigid. And worked in room temperature, in ambient pressure, and under ambient pressure. And what you wanted to do at that time is just to show that you can do atomic resolution. And a very good sample for that was graphite. And at that time, since in the C direction, graphite has a very low binding chemically, so you just can peel it off. Nowadays you call that exfoliation.
With a Dutch tape.
With a Scotch tape. So I peeled it off, and it didn't work sometimes, and then I tried to image it with the STM, with that new developed STM. And it didn't work sometimes, and then I had all this sellotapes all over my working bench, and it had graphene on it, and we didn't know. So on both sides there was graphene, and when I found a very clean surface, that is what you actually was after, cleaning the surface of the graphene in order to get atomic resolution. We saw the hexagonal structure of graphene. So every 6 atoms, and because of in graphite you only see the out of energetically you only see the 3 atoms, right? And so there were 6 atoms, and that was the highest resolution at that time we had with the STM. What we didn't know is that we were imaging graphene. So down went another Nobel Prize. So that's a good. I think this is a good anecdote, you know.